Hello and welcome to your lesson for today. So if you have not done the practice proof worksheet, it is two-sided. Please make sure that you do that worksheet first before you watch this video. You want to give this a try before you're looking at the reasons so that you are practicing being able to justify things and give reasons for your test that's coming up tomorrow. So please, please, please make sure that you are practicing this stuff and not just watching the video, because everything makes sense when you hear it. So give it a good try and then go back and watch the video. So if you need to pause, all right, here we go. Here's some solutions here. So name the property. So it says 3x equals 120, and the next side it just says x equals. So what did they do to get rid of that 3? And most of you are going to tell me that they are going to divide. So it's the division property of equality. Now remember that you could also multiply, because you could be multiplying by 1/3 instead of dividing by 3. All right, in step 2, we've got 12 equals AB, and in the next one, it's AB equals 12. So they're switching them on the equal sign. This is called the symmetric property of equality. Symmetric property of equality. All right, in number 3, A plus B equals 180, and now they're telling you B equals 30. Okay, so this is not an A, B, B, C kind of thing, because that's all new information. A, B, B, C. So what we're going to do here is instead of writing A, they put something, whoops, not A. Instead of writing B, they put something equal in place of B, because they're telling us B is 30. So this is your substitution property. So make sure you write it out long enough that I know you mean substitution and not subtraction. All right, 5x minus 4 equals 6, and the next time it just says 5x. So what happened to that 4? Well, they did the addition property of equality. All right, this next one is a proof. So if you recall, I said most of the time step 1 is going to be given information, but occasionally we get our information from a diagram. So why can they tell us that CE, the big segment, is equal to CD plus DE? So remember, this one is not just given, this is from looking at the diagram, and this is called segment addition. So this is the segment addition postulate. All right, in the next one, instead of writing CE, they wrote 6x, because that's what the whole thing is. And instead of writing CD, they wrote 8. So this is the substitution. They're putting equal things in place of something else. All right, on the next one, what did they do? So now they have a 15 over there and a 3x. So this is called combine like terms. Or you can say that they are simplifying. So simplify. You can write either one. You do not have to write both. All right, what do we do in the next one? Well, it looks like we subtracted 3x from both sides. So subtract, again, make sure you write enough letters so I know you mean subtract and not substitution. And then in the last one, most of you are going to tell me that they are going to divide by 3. So it's the division property of equality. Or remember, you can call that multiplication, because they could be multiplying by 1/3. But the big thing here is the first statement is segment addition. It is not just given information. All right, this next one we have angles here. So instead of segments, we're dealing with angles. But otherwise, it kind of looks very similar to that last proof we did. So PQR is the smaller angle PQS plus SQR. So we're going to call this one the angle addition postulate. So this is angle addition. Okay, then again, PQR, we know that that's 90 because they have that right angle. So we are substituting equal values in place. So substitution. All right, in the next one, it looks like we're cleaning things up a little bit. So we've got 2x plus 4x. So again, this one is called combine like terms, or if you wanted to, you could call it simplify. And in the next one, it looks like they are using the addition property of equality because they are adding 12 to both sides. And in this next one, they are using division, or you could say that they are multiplying. Now, most of the time, most proofs will not leave it like this. So obviously, I wouldn't expect you to do this, but just in case they throw this on here and they say x equals 17, how would we justify that? What reason do we have for putting the x first? And that's called your symmetric property. Symmetric property of equality. All right, here. So name the property. So what property? So in here we've got angle ABC is DEF, and now DEF equals ABC. Well, that's that last one that I just used in that last proof. So this is the symmetric property. All right, 1 equals 2, 2 equals 3, so 1 equals 3. So this is having three different things, an A, a B, and a C. So now we can say that A is C. This is called your transitive property. So F equals HJ, and HJ equals FG. This again is your symmetric property. And let's see, it looks like the same exact things on both sides. So remember, that's like looking at your reflection. So this is called the reflexive property of equality. All right, on the other side of your worksheet should be a couple proofs. So this is totally writing the proof from scratch. So we're going to make sure that we write statement and we write reason in here. And this is called a two-column proof. Statement and reason, and remember we number these. Okay, so how all proofs are going to start either from getting information from the diagram, or you're going to start by putting in the given information that they gave you. So they are giving you that TU is congruent to UV. This is given information. All right, step 2. Well, they want us to prove that SU plus TU equals SV. So we need to get this SU and this SV somehow in our proof. So can we say SU plus UV equals SV? And what reason do we have for that? And that's going to be segment addition. Well, this looks very close to what they want us to prove, but instead of this TU right here, they want us to have TU and we have UV. But what do we know about TU and UV? They are equal. So can't I write SU plus TU equals SV? What property allows me to do that? And that is the substitution property of equality. Because right away in step 1, they tell us that those two things are equal, so I'm going to substitute that value in. All right, I think we have one last proof here to run through. So why are they telling us that RS is congruent to UV and ST is congruent to VW? Well, that is your given information. They just plain and simply tell you that. Now, what do they do from step 1 to step 2? So this is one that I said I'm not going to be super picky about when you guys are writing your proofs. But in technology, when you're writing code for things, this step would be very huge because things are not going to write unless you have every single little step. So this one right here, when you go from equal to congruent or congruent to equal, this is called the definition of congruent segments. So if you're writing a proof from scratch, I wouldn't expect you to put this in. It's awesome if you do, because you really should. But if you ever have a proof where it's filled out, I do expect you to know what that reason is. All right, so now what are we going to do here? So if you look here, we've got RS and RS, so those are the same. But now all of a sudden they're putting ST in here. Well, they're adding this ST on one side and they're putting VW on the other side. And because they are equal, isn't that the addition property of equality? So we're adding equal things to both sides. All right, now what do they have? RS plus ST. So RS plus ST equals the whole thing RT. Then on the bottom, they have UV plus VW is the whole thing. So this is your segment addition. All right, now here we have RS plus ST, so we have RS plus ST. Those are the same things. So now, instead of writing this, can't we put RT in place of it because it's equal to it? And likewise, the same thing with the other one. So this is called substitution when you're putting something equal in place of something else. And then what do they do from 5 to 6 is they put that congruent mark back in. So in a proof, if it's already written out, I would expect you to be able to come up with this definition of congruent segments. But if you're writing a proof from scratch and you just stopped at step 5, I would not mark the last step wrong. All right, hope this was a good review for you and you guys are ready for your test that's coming up.